Today we'll be working on the following problem. We want to evaluate the limits of this two integral. So pause the video if you want to work on this problem by yourself. Okay, let's see how to compute this two integral. So first, we notice like, okay, n goes to infinity, like the integral up limit is n, and then inside the function. So both are related n. So we want to first simplify this. For the first integral, it can be written in this form, to the n e to the x over 2 dx. Now we do the change of variable. Let x equal to minus u. This becomes from 0 minus n 1 plus u over n to the power of n and e to the minus u to 2, and then minus 1 and du, right? And now we can change the upper limit and lower limit because you have minus 1 here. So this actually from minus n to 0, 1 plus u over n to the power of n minus u to 2 and du. And then we want to write in the following format, which is from minus infinity to 0. But here we use the characteristic function from minus n to 0 of u, and then 1 plus u over n to the power of n e to the minus u over 2 du, right? This is the characteristic function over minus n to n. The reason we're using this is like, now if we set f sub n of u, this sequence, because it involves n, is the characteristic function from minus n to 0 and u 1 plus u over n to the power of n e to the minus u of n, right? So here we want to see if it can be bounded by some Lebesgue integrable function, and then this also sequence goes to some function, and we can apply the Lebesgue dominant convergence theorem to pass the limit into the integral itself, right? So here this goes to what? Goes to when n goes to infinity, this one goes to 1. This part goes to 1 from minus infinity to 0, right? And now this one goes to e to the power of u, and then times e to the power minus u over 2. This is e to the power of u minus 2. When u is in minus infinity to 0. So this one goes to this function. And now is this, and then also like f, we use the inequality. We want to estimate this. This is bounded by what? So we know e to the x is always greater than or equal to 1 plus x for all x in R, right? We use this inequality, so this one is at most e to the u over n, and then raise the power to n, and e to the minus u over n. And now this is e to the minus u over 2, right? So now we have a sequence goes to a integrable, goes to a function e to the minus u over 2, and also this function is positive. This one is is clearly measurable from minus infinity to 0 and is positive, right? And then is bounded by e to the minus over u. Now let's check from minus infinity to 0, e to the minus u over 2 du. This is exactly like, okay, we have anti-derivative 2 to the 2 times e to the minus u over 2, and then from minus infinity to 0. This is 2, right? The integral is 2, which is finite. So we have all the conditions of Lebesgue dominant convergence theorem by this. So we can pass the limit into the integral itself. So by this, we have this limit n goes to infinity, the original one from 0 to n, 1 minus x over n to the power of n e to the x over 2 dx. So this is actually, as we said, n over, by the change of variable, we know this is just from minus infinity to 0, and then f sub n of u du, right? Because we can then apply the Lebesgue dominant convergence theorem, passing the limit into this, which is from infinity to 0, and then a limit n goes to infinity, fn of u du. This is exactly from minus infinity to 0, and since this limit, as we calculate, which is e to the power of minus u over 2 du, right? This is 2. So for the second one, similarly, for the second one, we have this limit n goes to infinity, this interval from 0 to n, 1 plus x over n to the power of n, and e to the minus 2x dx, right? And now if we do the same thing, this can be written as limit n goes to infinity is from 0 to infinity, and characteristic function from 0 to n, x, and 1 plus x over n to the n, e to the minus 2x dx. Now if we define this to be our f sub n of x, we can see f sub n of x is positive, measurable over 0 to infinity, and this one also goes to what? Goes to this goes to 1 plus x over n to the power of n goes to e to the x, right? And then times e to the minus 2x. So it goes to e to the minus x for all x in 0 to infinity. And then I see fn of x is bounded by when n goes to infinity, or any for any n, right? This is at most 1, and then we use the same inequality, e to the x is greater than or equal to 1 plus x. This is less than e to the x over n to the power of n times e to the minus 2x, which is e to the minus x. So it's bounded by this. And also from 0 to infinity, e to the minus x dx. This antiderivative is minus e to the minus x, and then from 0 to infinity, and we have this equal to 1, which is finite, right? So we have all the conditions satisfied for we to apply dominate convergence theorem. So finally the limit and goes to infinity, 0 to n 1 plus x over n to the power of n e to the minus 2x dx is just the integral from 0 to infinity e to the minus x dx, which is 1. That's it.